My name is Michael. I'm here today to talk to you about AWS Simple Systems Manager. I'll demonstrate and explain how you can use Systems Manager for a hands-off approach to server management and automation. I'll assume some AWS knowledge of the common services, but I'll do my best to go into enough detail without going to too many rabbit holes. I hope you enjoy. Let's start with some introductions. My name is Mike, currently working as a Senior Engineering Manager at Peak AI. I lead the DevOps team at Peak, empowering developers and data scientists to be autonomous, self-sufficient, and effective by building secure infrastructure and automation into AIS, the cloud-based AI system for the enterprise. And a little bit about Peak. Peak is helping customers overcome barriers of entries to AI. So some of those barriers may be the time and expense of building systems, hiring machine learning and data science experts. We use our tools and our talent to quickly and effectively help clients identify opportunities in their data. We're building an end-to-end AI platform. From ingesting data to unifying it, transforming it, building machine learning models to extract even more insights, and then providing valuable output in the form of visual dashboards, API endpoints, or even just raw data. We provide off-the-shelf solutions that allow us to speed up putting AI into the enterprise right through across the business. And last but not least, Peak is an AI consulting partner with both machine learning and retail competency statuses. The Systems Manager is the central place to view and manage resources. Visibility through a unified user interface, and ultimate control of automation, operations across your cloud. Central application management across EC2, S3, RDS, and more. Effortless monitoring and troubleshooting. Simple, secure, at scale. To provide some background and context, I'm going to go through some use cases. These are not the only way things can be done, but simplified use cases based on common patterns that I've encountered and less than ideal scenarios that I've dealt with, not just being at Peak, but just being a DevOps engineer in general. Something quite common in the system administration world is the use of Bastion hosts, also known as a jump box. It's a special purpose computer on a network hardened to withstand the potential threat of being hosted publicly. System administrators, engineers, developers, they connect to the Bastion host and then jump into the private network to manage the services. This means that the application servers, databases, and so on don't need to be in public subnets. They can be in a private subnet, and then just a few hardened Bastion hosts are made public facing. So how do the system administrators connect to the Bastion host? Usually SSH, secure shell. Some may use RDP, remote desktop, but for this example we're going to use SSH. In SSH, we hopefully have configured the need for a PEM file. We'll keep it simple here, but ideally the key can be protected to have a passphrase, so can the user logging in too. But what if lots of engineers need access? Tens, maybe hundreds. It's often in human nature to get a little bit lazy and do things like sharing keys. What service can you think of that would be quick, convenient, cost-effective for storing files that can be accessed by different users and applications? That's right, Amazon S3. It's not the best practice, and it's not the only way, but it's an example that I've seen more than once, and it's quite a good use case for what I'm going to talk about later. I just hope that that S3 bucket is not public. Just having the credentials to connect to the server isn't enough. We of course need to open the server up in some way to be able to connect from the outside. We can do that with a security group that exposes the port on the server, in most cases port 22. Again, we have tens or hundreds of engineers, and it's not very straightforward to whitelist IP addresses and ranges, and far too often they end up remaining open to the entire world. So what's wrong with that, you ask? Well, this leaves us vulnerable to a few threats. For example, port probing, sending requests to the server to find out information about it. Things like the operating system. Even without gaining access, an attacker could gather information they need to find out what they can exploit. For example, are you running an outdated version of the operating system? Are you not fully patched? Worse than that comes brute force attacks. Intruders attempting to gain access by guessing credentials. They may overload the server, or worse, succeed. So I got curious about the risks and the likelihood of these incidents happening. So I decided to do an experiment. I launched an EC2 instance, and then I exposed port 22. Now AWS provides a service called Guard Duty. Guard Duty monitors VPC flow logs, CloudTrail logs, DNS logs, and then provides intelligent threat detection using machine learning. So if there is any suspicious or malicious behavior in the account, you get an alert. Now, believe me when I tell you, it didn't take long to get this notification. Okay, probably. Not too bad, not too worried. But I left the server running overnight to gather some more findings. And bingo, an attacker attempting to brute force their way into my instance. I don't think I've done anything wrong to anyone in particular, but there are bots and scripts scanning the internet for open ports and vulnerable systems every second, and they won't take pity. Coming back to engineers and developers, what is something that they love to do? That's right, automate. So imagine the system administrators want to manage and maintain many servers. It's only productive to automate that by writing scripts. Hopefully they've shared that script and that code with the rest of the team, keeping it version controlled in a platform like GitHub. But let's just hope that none of those commits include secrets that may get exposed to the public. We've gone through a few problems and unfortunate cases. It may be easy to blame AWS for making it so easy to make S3 buckets public, or blaming the developers for hard-coding secrets, or to call the hackers mean for picking on us. Or we can learn from it. We are human after all, and we all make mistakes, now and then. So let's look at some solutions that may help reduce the likelihood or effect of any mishaps. So we found some keys in S3. Maybe you've inherited or support a legacy application. Maybe you've given developers and engineers autonomy that they need to get the job done. In a moment of weakness, they've made a mistake and you've intervened too late. Maybe you saw it there all along and didn't really think anything of it. But what is the most common exploit of AWS that we hear about when people talk about data breaches? It's S3 buckets, public to the world. This makes me think about a security principle that we should consider: reducing the blast radius. Exposing data is bad. It's terrible. But exposing the keys to the applications that hold, manage, and utilize the data, disastrous. And when we're hosting servers that are potentially vulnerable to probing and brute force attacks, we need to consider another security principle: reducing the attack vector. What if we could just remove the bastion host altogether? Terminate the bastion host and throw away the keys. If we don't have the keys, we don't need to store it in a central place like S3. We wouldn't need to expose port 22. But then how would we manage our instances? Well, that's where Session Manager comes in. You can interact with Windows and Linux instances using a browser-based shell and the command line instance. So now I'm just going to dive into a quick demo and show some of the features, some of the things you can do with Sessions Manager. Two EC2 instances that I've created for demo purposes. One is running Amazon Linux 1, one is running Amazon Linux 2. Both of these, using the latest AMI, come with the SSM agent pre-installed. You'll notice there's no key pair for SSH. I've used an IAM role that provides SSM permissions that are required. It's deployed in a private subnet. And if we look at the security groups, there are no inbound ports open. We don't need them. Instead, I've created a VPC endpoint, one for SSM and one for SSM messages. This allows any traffic to SSM to be routed using the AWS network and not out to the internet and back in, which means we don't need to open any ports. These are deployed in private subnets. If I want to quickly create a session, I select the instance, I go to connect, I pick Sessions Manager, and I connect. And I have my session. Once I'm done, I can terminate the session. This doesn't terminate the instance. Now if I go to Systems Manager, I can look at the managed instances and see my two instances in the list. I see information such as the platform name, the versions, internal IP addresses. If I want to run a session, I can do that from here too. I can look at the session history and see the previous connections that I've made. These are previous sessions that are now terminated. If one was running, I could terminate it. Now another problem I often face is excessive permissions. Maybe identity and access management is too complicated, but we should always strive to follow the principles of least privilege, giving users and applications what they need, nothing more. It's often easier said than done, especially when moving at great pace, but we've got to try not to get lazy. And honestly, a lot of the time, it is just trial and error until you get it right. But I have to say, looking at the Sessions Manager and the choice of permissions, they don't seem extensive. I can describe, start, reduce, and terminate sessions, but that's it. We should still make sure that we limit the roles and the policies and the users. So for example, limiting the users that actually have permission to start sessions. In addition, something we can do is enforce users to only be able to access Systems Manager if they have been granted access to a particular KMS key as part of their IAM policy. If they don't have access to the key, they're not creating any sessions. But they don't need to know anything about that key. They certainly don't need to share it around or store it in S3. Creating an audit trail doesn't prevent anything happening, but it does help for debugging and analysis. We can check quite easily the previous and current sessions via the console, but we can also log connections made and even generate a report connection made to your instance over the past 30 days. We can use CloudTrail to log API calls made within the account, Systems Manager console, the CLI, Systems Manager SDK, and that information can be viewed by the CloudTrail console or stored in a specific Amazon S3 bucket. We can also log the data that comes from the commands. We can store and encrypt the log data for all the sessions in an S3 bucket, or we can stream and encrypt the log data for all sessions into a CloudWatch logs group. We can even generate notifications for session activity to SNS, or even Lambda, code pipeline, or run commands, which we'll come to soon. Another common scenario is connecting to tens, hundreds, thousands of servers simultaneously for patching and maintenance. Because, let's face it, who could bear to do it one by one? Remember, engineers love automation. I've had some real fun writing scripts and tools to automate and manage these sorts of things. I've seen and used other people's code and other companies' projects that were incredibly sophisticated. But as is often the nature of scripting and code, I've also seen things go wrong. That's not to say there'll be no mistakes using Sessions Manager or Systems Manager, though. So, to simplify this kind of activity, we can make use of run commands and run documents. Run documents define actions and input parameters. They can be written in YAML or JSON. There are different types that can be used with different features of Systems Manager, and they can be shared. So imagine writing scripts that need to be run in multiple accounts. Rather than copying the document from one account to the other, having the same version of the code in multiple different places, losing track, updating some, not updating the other, or just create it in one place, share it with those other accounts, and allow those accounts to run those commands on the instances in that account. A run command allows us to remotely and securely manage the configuration of an instance at no additional cost. You could choose a document to run, pre-configured by Amazon, or one that you made yourself. Pass in parameters, and then you select targets. Targets can be selected manually using instance IDs, or they can be selected using tags. We use tags to identify, define, and categorize resources, not just for cost allocation. So, for example, select all the instances with a stage that is equal to prod. Tags can be added by the console, command line interface, SDKs. If you deploy an infrastructure as code, you can use CloudFormation to add the tags into your templates. If you're using a serverless framework, you can add tags to function the resources as part of your configuration there too. So there's really no excuse. Then you can also use tags to create resource groups and select those as a target. And then there's a few other options and parameters which we'll skip over now, but instead we'll dive into a quick demo. Let's take a look at SSM documents and how we can use them to run commands. Here we can see some SSM documents. We can filter by those owned by Amazon, owned by me, and shared with me. There's a few other options to filter too. We can go through the documents and we can find the document that we want to run as a command. We can look at the content, the details, different versions, and we can run the command. This command allows us to pass in shell scripts or commands to run. We can set the working directory, execution timeout. We need to set the targets. So we're going to use tags. Every instance with these tags will run the command. We can add comments, timeouts, rate control, output to S3 or CloudWatch, alert with SNS notifications, and we can even see the command that we would need to run on the command line. While the command runs, the status will be pending and in progress. We can look at the description, the parameters. If we refresh, we can see that it's now successful. So we can check the output. If we want, we can even rerun the same command with the same parameters. Hopefully the result is the same. But there is something I think you should know. I think you should be aware of this. Run command parameters are not kept secret. In this example, the parameters of user and password have been displayed in plain text by the console for anybody that has at least read-only access to Systems Manager. Because there is no secret parameter type or no echo options. The different parameter types, string, string list, boolean, integer, map list, and string map, but no secret string. The display type, you have text field or text area, but nothing that masks the input given from the user. And the run command output will not be kept secret either. The output is often useful as long as you're not outputting anything confidential. All the more reason to lock down permissions. Earlier we considered that passwords and keys could be accidentally committed to source control, things like GitHub. Especially if the repository is public, you're likely to have a problem to deal with very quickly. Instead, we should make use of dynamic variables and references. So shred up the post-it notes with all your passwords written on. Let's take a look at Parameter Store and Secrets Manager. Parameter Store acts as a central store. It allows you to store data such as passwords, database strings, Amazon machine image IDs, license codes, all as parameter values. Secrets Manager lets you easily rotate, manage, and retrieve document credentials, API keys, and other secrets throughout their lifecycle. Both features allow you to store values of plain text or as encrypted data using KMS, the key management store. And these services can be integrated into other popular AWS services such as ECS, Lambda, CloudFormation, Secrets Manager, Code Build, Code Pipeline, and Code Deploy. Next, let's look at some examples of integrated parameter store and Secrets Manager. Just see how easy it really is. So starting really simple, using the command line to fetch a plain text parameter. AWS, SSM, get parameters, and then you pass in a name or a list of names. If you want to write in Python, use the SDK, both for 3. You can do that, and you can use that to fetch a secure string. That string would be encrypted with the KMS, so note the with decryption equals true parameter that you pass in to the get parameter function. Here we have a CloudFormation example. So we may have a property of a resource, and then we can resolve the value of a parameter store secret string, and then use that as the value for that property. So resolve colon SSM-secure, and then the name of the parameter. A very similar example for fetching secrets from Secrets Manager. This time we use resolve colon Secrets Manager, and then the name of the secret and the key of the value you want to return. So let's have a brief comparison of Parameter Store or Secrets Manager. Both of them allow your values to be encrypted using KMS. Both are compatible and can be integrated with CloudFormation, CLI, and the popular SDKs. In terms of cost, Parameter Store comes with no additional cost, whereas Secrets Manager does charge per secret and per 10,000 API calls. Secrets Manager comes with a few extra features, such as automatic secret rotation and generation. So Secret Manager allows you to automatically rotate the secrets for a secured service or database such as RDS, Redshift, or DocumentDB. And because Secrets Manager also comes with a built-in password generator, you could provision a resource, give it a password that is saved in Secrets Manager. The applications can call Secrets Manager and get those values, but the humans, the users, the developers, they never need to see those values. In fact, we can rotate those values. Secrets Manager is up to date, and the application never ends up getting the old value. You know, if you were to rotate it yourself manually and then update these parameter stores, you know, how many different places are the keys being used? In this case, we're always going to get the up-to-date version. We keep it secure because it's rotated automatically. But the principle of least privilege isn't as easy as we thought. It has been said that the managed policy that AWS provides for read-only access is way too open, providing more permission than it should. This is an example where a role that has a read-only access policy attached is actually able to reveal the secret string and parameter store. Maybe it's not so secret after all. But on the plus side, the read-only access policy attached to a role does not allow you to reveal Secrets Manager secrets. Sometimes, I guess, you get what you pay for. Thank you for following me through some of my favorite features of AWS Systems Manager and Secrets Manager. I hope you found it insightful. I hope you take the time to shut down those Bastion hosts, throw away the keys, shred those post-it notes with passwords on, and remember, encrypt everything. Thank you.